What can happen in 3 milliseconds? Well, a neuron can fire, sound can travel about a meter, a housefly can flap its wings, and a voltage sag can crash a data center. Welcome to the era of electrical impeccability, the age of perfect power. The question is, are we ready for it? And the short answer is no. And yet, it's what our world more and more demands. Not just reliable power supply, but perfect power quality, where brief harmonic distortion can halt a materials processing line worth millions per hour, where power quality issues invisible to the human eye can compromise patient safety in operating rooms. This is our new reality. We're building a civilization that increasingly requires electrical perfection to function. When Thomas Edison pioneered the electric power system roughly 150 years ago, he mostly envisioned lighting our homes and streets. He couldn't have imagined a world where electricity would run our commerce and finance, healthcare, transportation, public safety, and global communications. The ability of the system gives way to reliance on the system, and where that reliance most definitely includes power quality. It starts, of course, with the rise of microelectronics, the proliferation of computers, consumer electronics, and automated industrial controls. Think about robotics, variable frequency drives, Internet of Things devices. This has introduced equipment that operates on very precise voltage levels. What a robust analog 1970s electric motor would just shrug off, a modern programmable logic controller cannot tolerate. Second, interconnected systems and processes. Modern business and industrial operations are highly integrated. A power quality disturbance in one area, such as a voltage sag, can cascade through a link network, shutting down entire production lines or data centers, and leading to significant financial losses and operational downtime. The just-in-time manufacturing processes and cloud-based services we depend on have created chains where the weakest link is often power quality. Third, the nature of modern electrical loads. Many modern electronic devices use power electronic components and switch mode power supplies. Think LED lighting, computers, EV chargers. These are non-linear loads, which paradoxically create their own power quality issues, such as harmonic distortion on the electrical grid. This distortion can further degrade the power available to other sensitive equipment. We've created a vicious cycle. Sensitive equipment that both demands clean power and pollutes the power supply for its neighbors. Fourth, decentralized power generation. The integration of variable renewable energy sources like wind and solar has introduced more fluctuations into the traditional centralized grid. The intermittent nature of these sources requires advanced management techniques to maintain stable voltage and frequency, increasing the complexity of ensuring consistent power quality. Fifth, data management and automation. In the age of Industry 4.0 and smart grids, reliable power is essential for data integrity and automated decision-making processes. Power quality is no longer just a technical issue, but a fundamental component of grid performance, utility economics, and customer satisfaction. So, would Edison squint at our modern challenges? Would he marvel at our dependence? Here's the paradox. As we make our grid greener and loads more sensitive, we're simultaneously making power quality harder to maintain, while the consequences of poor quality power become more severe. Let's unpack that. Traditional power generation, coal, natural gas, nuclear, hydroelectric, provided inherent grid stability. Large synchronous generators with massive rotating masses acted as shock absorbers, smoothing out fluctuations and maintaining consistent frequency and voltage. Renewables, however, don't work that way. Solar and wind are inverter-based, connected through power electronics rather than rotating machinery. They lack the inherent inertia that traditionally stabilized our grids. So when clouds pass over solar farms or wind speeds fluctuate, output changes rapidly, creating voltage variations and frequency deviations that ripple through the system. As attractive as renewables are, physics always wins. So this creates challenges at every level. Industrial facilities produce harmonic distortion from variable frequency drives in power electronics. Data centers require power quality measured in microseconds. That's 1/1,000,000th of a second, but also create power quality issues for the grid. Commercial buildings with smart systems present power factors far from unity and challenge harmonic spectra. The residential loads are transforming. Solar panels, battery storage, EV charging, smart appliances. Each one is a benefit to the consumer and a source of potential power quality problems. I've just described some of the pretty wicked challenges. Now here are the opportunities. Brilliant minds are developing, investing in, commercializing, and improving upon cutting-edge solutions. We now have systems, for example, that can detect power quality issues in microseconds and predict problems before they occur. Real-time monitoring combined with AI-powered forecasting gives us unprecedented visibility into grid conditions and load behavior, enabling proactive intervention rather than reactive response. Active power conditioning devices, including harmonic filters, StatComs, and dynamic voltage restorers, can now respond to disturbances in milliseconds. These systems inject or absorb reactive power, correct voltage sags and swells, and filter harmonics in real time, managing power quality even as grid conditions fluctuate. And energy storage and grid edge intelligence like battery systems and advanced inverters provide fast responding support that stabilizes voltage and frequency while managing the intermittency of renewable sources. So what does that mean for us today? Well, we need to elevate power quality from technical specialty to strategic imperative. We need to invest in infrastructure, technology, and expertise. We need to design our facilities, equipment, processes, procedures, and systems with power quality as a primary consideration, not an afterthought. In a world demanding perfect power, good enough isn't good enough anymore. Remember, this is going to be the most impactful decade in energy in a long, long, long time. And the decisions we make now will determine whether we successfully navigate this transformation or stumble through costly failures. We're not just building a more reliable grid. We're building a power system for a world that increasingly depends on perfect power to both function and thrive. Would Edison squint at our challenges? Probably. Would he smile at our opportunities? I believe so. Because despite the complexity, despite the paradoxes we've created, perfect power is increasingly required and more in reach. Let's get to work. For continued conversation and exploration of these ideas, connect with me on LinkedIn or at leb@blevensglobal.com. That's BLEVEANS global.com. You can also check out other episodes of Edison Squints on YouTube, and please subscribe while you're there. Thank you very much.